I love to look out over the range.
Often the lowest of the median rocks.
As an average man, I prefer the mean.
Located in the Black Hills of South Dakota, Mount Rushmore is a monumental sculpture carved into the side of a mountain, depicting four of the most famous and influential presidents in the history of the United States of America: George Washington, Thomas Jefferson, Abraham Lincoln, and Theodore Roosevelt. The idea for the sculpture was suggested in 1923 as a way to bring visitors to South Dakota, and sculptor Gutzon Borglum was selected to create it. Congress approved the project in 1925, but work didn't begin until October 4, 1927. Over the next 14 years, 400 workers blasted more than 400,000 tons of rock off of the mountainside using dynamite, finishing the details with jackhammers and chisels. Despite the dangerous conditions, no one died during the construction of Mount Rushmore. The face of George Washington was finished first in 1934, followed by Thomas Jefferson in 1936. Thomas Jefferson had been planned to stand on Washington's right, but when the rock on that side was found to be bad for carving, all the carving that had been done was blown off with dynamite, and he was moved to the other side. Abraham Lincoln's face was finished in 1937, and Theodore Roosevelt was the last one done in 1939. Mount Rushmore cost less than $1 million to complete. Originally, the sculptures were supposed to show the presidents down to their waists, but the builders ran out of money, and so they just made the heads. The heads of the presidents are 60 feet or 18 meters tall. That's the height of a 6-story building. Their eyes are each 11 feet or 3.3 meters across, and their noses are 20 feet or 6 meters long. Today, Mount Rushmore is carefully maintained to prevent cracking. Each year, trained mountain climbers scale the monument and seal tiny cracks before they can grow and cause parts to break off. Between 2 and 3 million people visit Mount Rushmore each year to see the colossal presidents, making it the most popular tourist attraction in South Dakota. I hope you enjoyed learning about Mount Rushmore today. Goodbye till next time!
So we want to learn about median and mode and mean and range as well. It's the different ways of finding averages from a set of data, from numbers. So yeah, pay attention.
Hey diddle diddle, the median's the middle. You add then divide for the mean. The mode is the one that you see the most, and the range is the difference between. Hey diddle diddle, the median's the middle. You add then divide for the mean. Ooh, the mode is the one that you see the most, and the range is the difference between.
Math class grades. Jonna has achieved the following grades on her math quizzes: 75, 84, 83, 81, 87, and 88. What is the mean of her grades? First, we add up all of her grades and get a sum of 498. Now we count the number of grades that she had. She had 6 grades, so we divide 498 by 6. 6 is unable to divide 4, but can divide 49 8 times. 8 times 6 is 48. I subtract and get 1. I bring down the 8. 6 goes into 18 3 times. 3 times 8 is 18, and I get 0. So the mean of her grades was 83%. What is the median of her grades? First, we have to put her grades in order from least to greatest. Then we count to the center. We don't have a center number, so we have to find the center of the 2 numbers that are there. What is between 83 and 84? 83.5. So the median of her grades is 83.5%. What is the maximum of her grades? The highest score she achieved was an 88%. What is the minimum of her grades? The lowest score that she earned was a 75%. What is the range of her grades? Well, we find the difference between the maximum and the minimum, which equals 13. So her range was 13%. What measure of center and variability would you use to describe Jana's math quiz data? Explain your reasoning. Well, we have various data landmarks here. What is the range of her grades? Well, the range would not be a good measure for her overall performance because it only takes into account 2 data points, the minimum and the maximum. We really could take away all the grades in between, all of her performances, all of her hard work in between, take that out, and the range would still be the same. So this is not a good overall representation of her performance. What is the minimum of her grades? This also only takes into account 1 data point, and she certainly would not want to get a final average of 75 if she had all of her performances were better than 75. What is the maximum of her grades? Again, this only takes into account 1 data point. Now, all of us would love to be judged on our best performance, but that is not an overall reflection of our grades. So while that would be awesome, it's not really true. What is the median of her grades? This takes into account all data points because we had to count each one to find the middle. And if we took out one of her grades, the median would change. So this might be a good representation of her performance. What is the mean of her grades? This also takes into account all data points. We had to add up each score to get a sum, and if we took one of the grades out, that would affect the mean. So the mean and the median are good measures of center and good reflections of overall performance. This is why in school we use the mean as your final average. Now, the mean would be here at 83 and the median would be here at 83.5. They're very close together, and the reason why is because her data is somewhat symmetrical. I don't really have any outliers here, so naturally the mean and the median would be very close together. So you really could use one or the other as a final grade to show her performance over this entire, let's say, marking period. Now, what if that wasn't the case? Let's say it's at the end of the marking period and there's one last exam, and she takes it, and if Jana gets a 118% on her next quiz, she got all the questions correct and the extra credit question too, how does this affect her grade? What is the mean of her grades now? We add them all up, and this time we get a sum of 616. We added an assignment or a quiz, so now she has 7 scores, so we're going to divide 616 by 7. 7 cannot divide 6, but it can divide 61 8 times. 8 times 7 is 56. Subtract, I get 5. Bring down the 6. 7 times 8 is 56. And I have nothing left over. So the mean of her grades now is an 88%. What is the median of her grades? We list her grades in order from least to greatest. Now I have an odd number of grades, so I do have a middle number, 84%. What measure of center and variability would you use to describe Jana's math quiz data now? Explain your reasoning. Again, we're going to make a graph so that we have a visual representation of her performance over the marking period. Notice I had to increase my number line significantly for her final quiz, which was a 118. Now look at the data. The median would be here, and the mean would be there. Now, which one is a better representation of her data? Well, when I look at all the information, I can see that for the mean, the mean's here, I only have one grade above the mean, and that is this 118%. All of her grades are at or below the mean. Now for the median, notice how the median is the median's in the center-ish of this group of data, okay? Yes, we have the outlier over here, but do you see how the median is like in the middle there? It's in the mix. So the reality is that she earned an 88%. She did a fantastic job on that last quiz. It bumped her grade up. So in her report card, she's going to get an 88%. But if I were to predict her next performance on an assessment, would I say an 88 or would I say an 84? Now, you would want to say an 84 because typically that was about her score on most of the exams. It was the last one that was dramatically different, which moved the median over. So you have to think about those things when you're picking and predicting future events. Pause the video and get out a sheet of paper and pencil. Draw a number line like the one below. Answer questions A and B. Unpause the video when you are ready. Students in a Saturday art class are 14, 18, 43, 14, 15, 18, and 11 years old. Let's make a dot plot to visually show the ages of the students in this class. Now, let's find the median. We list the ages in order from least to greatest, and we find the middle. 15 is our median age for the class. Now we find the mean. Add up all of the ages and we get a sum of 133. There are 7 students in the art class, so I divide by 7 and I get 19. So the mean is 19. Let's mark this on our dot plot. The median falls here and the mean falls there. So let's pretend that I'm an art teacher, or you're an art teacher, and you're preparing a project for this class. What kind of project are you going to pick? Are you going to pick a project, let's say, for toddlers, or one for teens, or one for adults? Will the median help you better, or will the mean help you better? Well, when I look at the median, I see that it is at the age of 15. When I look at the mean, then I see that the age is 19. So I'm definitely not going to have activities for toddlers because neither my median nor my mean includes toddlers. So a project for younger children would not be appropriate or of interest to this age group. Now I need to decide, am I going to do a project for teens or for adults? Well, the mean is telling me, 19, is telling me that I have adults in the group, along with teenagers. But a median of 15 is telling me, I have pretty much all teenagers. So which one is the better representation for this class? Well, let's take a look at the mean. The mean is at 19. But the reality is that I only have one person that is older than 19. That 43 made my mean skewed. It really impacted the overall mean. Now, the median is 15. And if you look at our graph here, most of the participants are around the age of 15. So a project for teens would probably be better than a project for adults. Okay, would this group really be wanting to make wreaths? Okay, probably not. They want to do some fun things, okay, or in their opinion, fun. Obviously, I think making a wreath would be fun, but then again, I am over here in my age group, okay? So, this is an example of where the median better represents the data than the mean. The outlier 43 greatly affects the mean. A mean of 19 means that all of the data falls below the mean except the outlier. This does not represent the data well. For this data set, the median is a better representation of the data. There are 3 data points below the mean and 2 above the median, not including the outlier. Thank you for learning about data landmarks today. And this is Mrs. Smith signing off.